Hello, welcome to week 4 of online learning. I wanted to give you a summary, kind of go over some of the information from lessons 6 and 7, and then explain lesson 8 and optional lesson 9 for you for this week. So, we started this unit looking at why the buffalo population changed so much from 1960 to 1975. So, we looked at this graph. And we were really focusing for the first part of this unit on the first part of the graph, which is what happened to the ecosystem to cause this huge change in the buffalo population, going from 20,000 buffalo to 80,000 buffalo in only the span of like 15 years. And we figured out in lesson 5 that what happened was there was a disease called rinderpest, and it is a virus, and it killed a lot of hooved animals on the Serengeti. So there were cattle that were domesticated, and they were the reservoir species for rinderpest. But the buffalo and the wildebeest were spillover species, meaning that the rinderpest couldn't live on its own in the buffalo and wildebeest populations. They had to get it from the cattle. So in the 1940s and 50s, there was a mass vaccination of cattle that lived in this area. And because of that, we saw rinderpest eliminated in this ecosystem. And so rinderpest was eliminated in early 1963, I think it was. And as a result of that, we see a population explosion, a huge population growth. So we figured out why the buffalo population increased, and that's because rinderpest was eliminated. So thanks, vaccines. And so we looked at this buffalo population and saw that the increase was significant. And then we also looked at the wildebeest population and saw that the wildebeest also experienced a huge population increase, and even a bigger one. So one of the things I want to point out to you is that the buffalo population was between 20,000 and 80,000. The wildebeest population jumped from 375,000, which is way more buffalo, even at its lowest, all the way up to over 1.5 million. So as you can see here, based on just the scale of this graph, there are way more wildebeest that live in the Serengeti ecosystem than there are buffalo. And the wildebeest also saw a huge increase after rinderpest was eliminated. So that brings us to the question of, well, what happens in 1975? Because both of these populations started to decline, and you see that they declined in very different ways after 1975, and we'll get into why that is. But what's going on? So what happened was the wildebeest exceeded the carrying capacity of the ecosystem. So if you did the simulation for lesson 7, you saw that when you started the simulation at different initial populations, you saw different graphs. So these 3 graphs here show what can happen at different population sizes. So some populations grow steadily, and then they plateau at this orange line, which is representing the carrying capacity. Some populations exceed the carrying capacity and then decline and plateau right about at the carrying capacity. And some populations, like you saw when you had the buffalo start at 100 buffalo, you saw that they already were exceeding their carrying capacity, so the population dies out. So the carrying capacity is really just this idea that ecosystems only have so much resources to support populations. So if a population consumes more food than the ecosystem can replenish, then they run out of food, which makes sense. And so we're talking mostly about grasses here, and the wildebeest population, as you saw, was so high. So let's talk about why this happened, why this change. So the wildebeest population plateaued. So we see that the population is a lot higher and goes not as drastically down as the buffalo population. And but also, why are there so many more wildebeest than buffalo? So we looked at in one of our early lessons, like lesson 2, I think, when we figured out what the buffalo eat, we figured out that buffalo don't migrate. And you saw this with the representation of buffalo fences in the simulation for lesson 7. But the wildebeest do migrate. And so what this means is that they can move around and access food in ways that the buffalo cannot. And so they can have a higher carrying capacity, meaning that the ecosystem can support more wildebeest because the wildebeest go out and get more food when they migrate, whereas the buffalo don't. The other thing we saw in lesson 6 was that there's some differences in the way that wildebeest and buffalo reproduce. So wildebeest reproduce sooner in life. They reach their age of sexual maturity earlier, and their gestation period is shorter, meaning that they are pregnant for less time, basically. So what that means is that they can make more babies. They can reproduce at a faster rate as a population than the buffalo can. So because of these two factors, the higher carrying capacity for wildebeest because they migrate and they can get more food that way, and because they reproduce so much more, we can see a significantly higher wildebeest population than a buffalo population. And so what happens is that the wildebeest have a huge impact on the Serengeti because their population is so much higher. And so what we saw in lesson 6 is the wildebeest had a huge impact on the Serengeti ecosystem. So because they exceeded their carrying capacity, that's upside down. Because they exceeded their carrying capacity, they overgrazed, meaning that while they were migrating, they ate too much grass. And when that happened, there was less grass in the ecosystem. And that resulted in fewer, weaker fires. So fires are a common occurrence in this ecosystem. There's a lot of thunderstorms that happen in the Serengeti and in a lot of sub-Saharan Africa. And so they get lightning. And lightning sparks wildfires all over the world. But specifically in this area, they experience a lot of wildfires naturally. And so if there's less grass, then there's less fuel for those wildfires. And so if there are fewer, less intense wildfires, then we can see the increase in tree growth because trees they start out small. They don't start out as big trees. And so when they're little saplings, if those saplings get burned, they're a lot easier to burn in a wildfire. But if there's less fire, then the saplings can grow and develop into larger trees, which don't burn as easily. And so we see more trees, and the presence of an increase in trees resulted in an increase in things that like trees, such as giraffes. So this is a crazy thing that scientists really didn't understand for a long time, is that some organisms can have a much bigger impact on an ecosystem than other organisms. And so what we saw here was the wildebeest overgrazing resulted in fewer fires, which is an abiotic factor in an ecosystem, which resulted in more trees, which resulted in an increase in other organism populations such as giraffes. So this led scientists to the conclusion that wildebeest must be a keystone species in this ecosystem, which basically means that a keystone species has a more significant impact on an ecosystem than other things. And when you remove a keystone species from an ecosystem, what you can see is significant ripple effects throughout things, directly and indirectly. And so these are examples of indirect results of a change in the wildebeest population. So, wow, wildebeest are keystone species. And I know that might seem kind of weird, like, but wait, weren't we talking about the buffalo? And the reason that we started with the buffalo is because that's what the scientists noticed. The wildebeest population migrates and was so much higher, but the buffalo population stays in one general area, and that's honestly what the researchers noticed first was, wow, I feel like there's way more buffalo around here these days. Don't you guys see that? And when they started to count the buffalo population, they saw that that was true, that the population was growing. And so that's actually what they noticed first. And that's why we started with it, because it's a very tangible observation. And then we travel our wonderful journey all the way to this idea that wildebeest are a keystone species in the Serengeti ecosystem. So the last piece of this unit that I really want you to get are what factors can cause changes in an ecosystem. So you have lots of ideas about what could cause populations to increase or decrease, but I wanted to highlight some that we discussed in this unit. So we talked about how maybe an increase in precipitation could cause an increase in food, and both of those could cause an increase in the population, but that's not what caused the buffalo to increase. What caused them to increase was the elimination of a disease, and that's also what caused the wildebeest population to increase. So the elimination of rinderpest caused an increase in the buffalo and wildebeest populations. What can cause populations to decrease? So diseases, obviously that's what was keeping the buffalo and wildebeest populations low for the beginning part of this experiment or this study. And then a decrease in water, which is drought, would cause a decrease in food availability. But we also saw that when a population exceeds their carrying capacity, they start to decrease after that. And so that's when you can really, if you look at population graphs, if you see a population grow and then decline, typically what that means in an ecosystem is that they exceeded their carrying capacity. And then what types of things can cause populations to remain stable? That would be no other changes in other factors and access to adequate resources, which you hopefully saw examples of all of these when you did the simulation or watched the simulation video in lesson 7. So that's wildebeest, you guys. That's the Serengeti ecosystem. I know that it was kind of a journey to get to this point. So this week we're doing lessons 8, which is our assessment. So there's 2 parts to the assessment for lesson 8. The first part is just like a straight up Schoology exit ticket, straight up Schoology assessment, just kind of putting those pieces together. And then the last part of the assessment for lesson 8 is for you to explain what happened. So I kind of just did that for you, but I really wanted you to explain it in your own words. So I kind of drew like a model. If that works for you, I would love to see your models. If you want to try and just write out the story, that's fine. If you want to just make a video and explain it to me like I just explained it over a video, that's fine too. So for lesson 8, there's not any new information. It's just those 2 parts, which is the exit ticket assessment in Schoology, and then the student activity sheet for this one is really just your explanation in whatever format you would like to explain it in. So both of those are available to you now in the lesson 8 folder in Schoology. And then lesson 9 is an extra credit extension opportunity. If you are interested in this idea of keystone species, they exist in ecosystems all over the world. They don't exist in all ecosystems, but they are significant parts of the ecosystems in which they exist. And so if you're interested in learning more about this, we've created some different opportunities. There's a really great video and some questions if you want to just dive into that. The video goes into like sea urchins and otters and then killer whales, and it's so good. I would highly recommend, even if you don't want the extra credit, just watching it is really interesting. Or you can research some other examples of keystone species. One that you might have heard about are the wolves in Yellowstone. So the wolves of Yellowstone have been introduced over the past like 50 or so years, and they have had significant impacts on the Yellowstone ecosystem. But there's so many other examples. So if you're interested in learning more about keystone species and maybe increasing your grade if you want, lesson 9 is an optional extra credit opportunity. You can do either the video or research and explain a keystone species that you want. Let me know if you have any questions. That's the end of this unit. So next week we will begin our last unit, which is a little bit, it's still about ecosystems, but it's a little bit more about like energy cycles and nutrient cycles. So we'll get into that next week. So required assignments this week is only the assessment for lesson 8, those 2 parts. And then if you want some extra credit, you can do lesson 9. Let me know what questions you have. Stop by office hours if you want to say hi or need help. I sent out a survey to everyone on Schoology for some feedback as we planned the last unit, and I would really appreciate your feedback as we design what this last few weeks of school is going to look like. Also, if you have any questions about how your grade is going to be calculated, I know that might be kind of confusing, or if you want to know specifically what your grade options are, depending on how much or how little work you do for the last few weeks of school, please let me know. Please send me an email, send me a Schoology message, text me, call me, show up to office hours, whatever. I'd love to have those conversations with you. So I miss you, and I hope that you're having a great day, and I hope to talk to you all soon. Bye.